Write a short note on Riemann sphere. Now, complex number can also be represented by a points on a sphere. For this, it is sufficient to establish a 1-1 correspondence between the points on a sphere and the points on a plane. The correspondence established by the means of the stereographic projections. For this purpose, we take a point n on the sphere as a vertex and the projection, and the equatorial plane as a plane of projection. Then any point A sphere except that their vertex of the correspondence a unique points a dash of a plane of conversely to each points of the plane, there is a correspondence of a unique point on the sphere. Analytically, we may proceed as let the sphere be a x square y square plus z square is equal to 1, and the point of a projection of b z is equal to 0. That is equation 2. Now let us take the vertex n as 0 0 1 and let x y z with the coordinates of the point A on the sphere and x y 0 with the coordinates of the point corresponding to point A dash in a line where NA meets a plane of projection. Since the points 0 0 1 x y z and x y 0 are in straight line, so we have x upon small x, y upon small y is equal to z minus 1 upon minus 1. This gives rise to capital X upon small x is equal to z minus upon minus 1. So small x bracket start z capital Z minus 1 bracket close is equal to capital minus of capital X. So small x is equal to x upon 1 minus z. Similarly, y small y is equal to capital Y upon 1 minus z, and small z is equal to x plus iota, y is equal to x plus x upon 1 minus z plus iota y upon 1 minus z, that is equal to x plus iota y 1 minus z, which is equation 4. Conversely, we get from 3 and 4 x is equal to 2x upon x square plus y square plus 1, where that is equal to z plus z bar upon z into z bar plus 1, that is equal to z plus z bar upon modulus of z square plus 1. Y is equal to 2y x square plus y upon x square plus y square plus 1, which is equal to z minus z bar upon iota bracket starts z into z bar plus 1 bracket close, which is equal to z minus z bar iota bracket starts modulus of z square plus 1 bracket close, which is equation 5. Now z is equal to x square plus y square minus 1 x square upon x square plus y square plus 1, which will z into z bar minus 1 upon z into z bar plus 1, that is equal to z modulus of z square plus minus 1 upon modulus of z square plus 1. The equation 4 and 5 are establish a 1-1 correspondence between the complex number and the points on a spherical surface, except that no points of the complex plane corresponds to the vertex n001 of the plane. This is a establish a defining the points at a infinity of the complex plane. The point at infinity is defined to be as the point of correspondence to the origin of the complex plane by the transformations z is equal to 1 upon z. Again, if xyz corresponds to the point of to x fix z, then the point xyz corresponds to the point as a fix as z dash. Z dash is equal to x plus 1 plus upon x plus iota y upon 1 plus z, that is equal to x plus iota y into x minus iota y 1 plus z into x minus iota y. So solving this, x square plus y square 1 plus z into x minus iota y, since x plus y square plus z square is equal to 1, so x plus y square is equal to 1 minus z square. So putting value 1 minus z square, and when we're substituting 1 minus z square as 1 minus z and 1 plus z, cancelling 1 minus z and 1 plus z gives rise to 1 minus z upon x plus iota, that is equal to 1 upon z prime 4. But z and z dash z is equal to mod of z into mod of z dash is equal to mod of z upon 1 upon z is equal to 1. So arguments of z and argument of minus z bar, arguments of 1 upon z and argument of z dash are equal, so that they are in inverse points with respect to the circle and with the center of the origin. So therefore the points of the Argand planes which are inverse points with respect to the circle correspond to the point of Riemann sphere, which are symmetrically with respect to the plane z is equal to 0. In the particular, when small z is 0, we get from 5 that x is 0, capital Y is 0, and z is equal to minus 1. So z is the point of infinity, and definition which therefore corresponds to the points as 0, 0 of the sphere. We denote that symbol to the infinity represents the point in infinity, the points of the complex plane together with the point of infinity from the extended complex plane. We agree that every straight line will pass through the point at infinity. We also see from 5 that hemisphere z is less than 0 corresponding to the circular disc modulus z is less than 1, and hemisphere capital Z is greater than 0 outside of modulus of small z is greater than 1. So therefore the function theory, we refer to the sphere discussed as Riemann sphere.